Hello everyone, welcome to new class. Today's class is about nodal analysis. So, in the previous classes we have discussed about mesh analysis, and in mesh analysis we are applying KVL to each loops, and this is nodal analysis, and in nodal analysis we are applying KCL to each nodes. So here we are applying KCL to each nodes. And what is node? Node means it is the junction of two or more elements. So node means the junction of two or more elements. So in nodal analysis, we are applying KCL at each nodes. So consider this circuit. So here we can assume this as one node, then here also another node, and here we can assume this as a third node. And suppose there are n nodes in a circuit, then one node will be considered as reference node. So here this third node is considered as the reference node, and in nodal analysis there will be n minus 1 nodal equations. And the reference node is assumed at zero potential. So there are three number of nodes in this circuit, and one is considered as the reference node. Reference node has zero potential. So the nodes in a circuit can be assigned a number or a letter, and the node voltage is the voltage of a given node with respect to one particular node called the reference node, which we assume at a zero potential. And in this circuit, the voltage at node 1 is the voltage at that node with respect to the node 3. Similarly, the voltage at node 2 is the voltage at that node with respect to the node 3. Applying the Kirchhoff's current law at node 1, that is, what is current law? The currents entering at a node is equal to the currents leaving at the node, or the sum of currents at the meeting point or at the node is 0. So at node 1, applying KCL, we can write here I1 is entering towards node 1, and through the resistors we assume the currents are leaving. So here we can write I1, that is I1 is equal to, at node 1 the current is V1, that is at node 1 the voltage is assumed as V1, and at node 2 it is V2. So we can write V1 divided by R1, and here R2 is between node 1 and node 2. So we have to write the voltage difference between these two nodes, that is V1 minus V2 divided by R2. And this one we can write, that is I1 is equal to V1 into here 1 by R1 and here 1 by R2. that is 1 by R1 plus 1 by R2, then minus V2 into 1 divided by R2. So this is the first equation. Now applying KCL at node 2. So at node 2, we can write here V2 divided by R4 plus R5, then plus V2 divided by R3, then plus here V2 minus V1, V2 minus V1 divided by R2, then equal to, here there is no current source, so equal to 0. So now we can rearrange this equation, that is here minus V1, that is minus V1 into 1 divided by R2, then plus V2 into 1 by R2 plus 1 by R3 plus here 1 by R4 plus R5. 1 by R4 plus R5 equal to 0. So this is the second nodal equations. So from these two equations, we can find the unknown voltages at each node. So this is the method for the nodal analysis. Let us do a problem. Write node voltage equations and determine the currents in each branch for the network shown. So this is the given network. So our first step is assign the nodes and voltages. So this is one node, this is the second node, and this is the third node. So now assign the voltages at each node, that is this is V1, V2, then this is the third voltage. So there will be 3 minus 1, that is 2 nodal equations. Now we can apply KCL at each node. So applying KCL at node 1, we will get, this is 5 ampere, that is 5 is equal to V1 divided by 10 plus here V1 minus V2 divided by 3. That is we get V1 into 1 by 10 plus 1 by 3 plus V2 into minus 1 by 3 or minus V2 into 1 by 3 is equal to 5. So this is the first equation. Now applying KCL at node 2. So at node 2, we will get V2 divided by 5, then plus V2 minus V1 divided by 3, then plus here we will get V2, then here plus 2 minus, that is negative voltage is there. So V2 minus 10 divided by 1 is equal to, here no current source, so 0. Then after rearranging, we will get here minus V1 into 1 by 3, then plus V2 into 1 by 5 plus 1 by 3 plus 1 is equal to, here 10 divided by 1 is there, so equal to 10. So this is the second nodal equation. So these equations we can write in this way, that is V1 into 0.43 minus V2 into 0.33 is equal to 5, then minus V1 into 0.33 plus V2 into 1.533 is equal to 10. Now we can simplify these equations using the calculator. So in the calculator, the mode is set in equation, then unknowns are 2. A1 is the first equation's first coefficient, that is 0.43. then B1 minus 0.33, then C1 is 5, then A2 next equation, that is minus 0.33, then B2 1.533, then C2 is 10. So the solutions are 19.9 and 10.8. So V1 is equal to 19.9 volt and V2 is equal to 10.8 volt. Now the question is to find the currents in each branch. So here through each branch we have to find the current. So through this branch, that is through 10 ohm resistor, that is I 10, we will get V1 divided by 10 and V1 is 19.9. So we can write 19.9 divided by 10 and that is equal to 1.99 ampere. Then through the 3 ohm resistor, that is I3 is equal to V1 minus V2. V1 is 19.9 minus 10.8 divided by 3 and that is equal to 3.1 ampere. Then through the 5 ohm resistor, that is I5 is equal to V2 divided by 5. V2 is 10.8 divided by 5 and that is equal to 2.16 ampere. And through the 1 ohm resistor, it is I1 ohm is equal to V2 minus 10. V2 is 10.8, that is 10.8 minus 10 divided by 1, that is 0.8 ampere. So these are the solutions for the given network. So in this way we are doing the nodal analysis. Let us do another problem. Determine the voltages at each node for the circuit shown. So this is the given network. So first of all we have to assume the nodes. So this is one node, let V1 be the voltage and this is the second node V2, then this is the third node and let V3 be the voltage at node 3 and this is the fourth node. So there will be 4 minus 1, that is 3 nodal equations. Now at node 1 applying KCL, that is Kirchhoff's current law. So we will get V1, this is plus 2 minus, so V1 minus 10 divided by this 10 ohm, then plus V1 divided by 5, then V1 minus V2 divided by 3. Also there is another 3 ohm resistor, that is plus V1 minus V2 divided by 3. Then here no current source, so equal to 0. Now we can rearrange, that is V1 into, this is 1 by 10, then 1 by 5 plus 1 by 3 plus again 1 by 3, then here minus V2 into 1 by 3 plus 1 by 3, then equal to here minus 10 by 10, that is minus 1. So in the RHS it will be plus 1. So this is the first equation and let us simplify these again. So we will get 0.96 V1 minus 0.66 V2 is equal to 1. So this is the first nodal equation. Then at node 2, so at node 2 applying KCL, we will get V2 minus V1 divided by 3, again V2 minus V1 divided by 3 plus V2 minus V3 divided by 2, and here 5 ampere is towards this node, so equal to 5. Now we can rearrange this one, that is here minus V1. So minus V1 into 1 by 3 plus 1 by 3, then plus V2 into 1 by 3 plus 1 by 3 plus 1 by 2, then minus V3 into 1 by 2 equal to 5. So after simplifying we get minus 0.66 V1, then plus 1.16 V2 minus 0.5 V3 is equal to 5. So this is the second nodal equation. Then at node 3 we will get V3 minus V2 divided by 2 plus V3 divided by 1 plus V3 divided by 6 equal to 0, because here no current source. That is at node 3 we will get V3 minus V2 divided by 2 plus V3 divided by 1 plus V3 divided by 6 equal to 0. Then after rearranging we will get here V1 is 0, then minus V2 divided by 2, that is minus 0.5 V2, then V3 divided V3 into 1 by 2, 1 by 1, then 1 by 6, that is plus 1.66 V3 is equal to 0. So this is the third nodal equation. So we get three nodal equations, and by solving these three equations we can find the values of V1, V2 and V3, and that is the question. So either we can go for the Cramer's rule or let us do in the calculator. So in the calculator the mode is set in equation mode, then unknowns are 3, A1 is 0.96, then B1 is minus 0.66, then C1 is, that is in the first equation V3 is 0, so C1 is 0, then B1 is 1, then A2 is minus 0.66, then B2 1.16, then C2 minus 0.5, D2 is 5, then A3 is 0, then minus 0.5, then 1.66, then D3 is 0, and the solutions are 8.07, then 10.8, then 3.08. So V1 is equal to 8.07 volt, V2 is equal to 10.8, this 10.8 volt, then V3 is equal to 3.06 volt. So in this way we are doing the nodal analysis. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.